Tonight's video is all about drawing line graphs. Now the video is one thing. You will probably need to watch it through a few times to make sure that you understand. Even so, you won't really feel like you know what you're doing until you've drawn maybe half a dozen line graphs or more. It's one of those things that the more you do, the more comfortable you feel with it. But until you've become quite comfortable, you really feel like you don't know what you're doing yet. So watch the video through a few times and be ready to come to class and work on it with me in the room when I see you. All right, so let's begin. First off, let's have a look at parts of a graph. A graph will first of all, and probably most importantly, include grid paper. Some of you will be tempted to rule up a graph, attempt to rule up some grid paper on your lined paper out of your folder, but that's just never going to be good enough. So if you need to draw a graph, you're going to want to get some grid paper from me. You might want to take some from your math book. It might also be worth buying a pad of grid paper that you can use for science graphs. You will also have two axes. The first one is the horizontal axis, or the x-axis. That's the one that lies flat. You can think of horizontal being the same as the horizon. There's also a vertical axis, or a y-axis. We'll come back to those in a minute. Let's look at some of the rules for drawing line graphs in science. Most of them will come as no surprise to you, and you won't need to practice them any more tonight. They are giving your graph a meaningful title. Calling it graph is not meaningful. So in class we might practice a few titles that are meaningful. Use a pencil. This is really important because it's very easy to make mistakes when you're drawing graphs. And if you've used a pen, you'll throw away pages and pages of paper before you're finally happy with it. So always use a pencil. Use a ruler for drawing up your axes and your line of best fit. More on that later. Label your axes. That means give them a name. Tell us what they're measuring, whether it's temperature or time or concentration. Give them a label like that. Put units on them. So tell us if you're measuring time, tell us whether you're measuring time in seconds or minutes or weeks or years. The independent variable always belongs on your x-axis. Now, if you're not sure that you can identify what the independent variable is, it's worth having a look back through your notes. It might also be worth watching the video called Types of Variables again. Always use an even scale. Now we're going to talk about that a little bit more in this video, but you won't really feel like you can draw an even scale until you've practiced a few in the classroom with me. Always use a line of best fit. Now, often that will be a straight line that you will need to draw with a ruler. But also, it may often be a curve that you won't use a ruler for. And your data and some experience will tell you when to do which. And of course, in the meantime, I will always help you. All right, this is our first look at an even scale. I haven't labeled every one of my vertical lines, but I have labeled every 5. So my scale, as you see it written in front of you, is saying 5, 10, 15, 20. But every one of those vertical lines in there represents 1. So if we start right from the very, very far left, we get 0. And then we get a line to mean 1, a line that means 2, a line that means 3, a line that means 4, and then the fifth one, the darker one, is the line that means 5. Okay? So that's an even scale that runs along our x-axis or our horizontal axis. Here I've started to show you an even scale running up your y-axis. You might notice that the scale running up the y-axis is not equal to 1. It's not the same as the horizontal axis, and that's fine. It doesn't have to be. As long as the x-axis is even and the y-axis is even, it's fine. So have a look at those first two numbers on the y-axis, 25 and 50. Predict in your head what the next 3 labels on the vertical axis will be. Do you think you have an idea? Let's check your answers. 75, 100, and 125. This has given us 2 even scales. Now, suppose you had some data that told you you needed to put a small dot at 5 along the x-axis and 25 along the y-axis. Where would that dot go? Have a think. How about right here? Now, when you're drawing graphs, you don't need to add the 5, 25. I've drawn that to help you remember what it was that I asked you a second ago. All right, let's try another one. How about 9 and 50? Picture it in your head. Where do you think that dot belongs? Right there. 9, because it's one vertical line back from 10, and 50 because it's on that 50 line. When you guys do this with pencil, you'll get even more accurate than I have. The reason I haven't been able to get as accurate as I like is because I'm stuck working on a computer with pictures. Finally, tricky one, let's try a dot at 12 and 65. Ready? Right there, 12 and 65. Okay, as you have seen, scales don't have to equal 1. Here, the x-axis has a scale of 1, but the y-axis has a scale of 5. In this diagram, in this example, the y-axis still has a scale of 5, but now the x-axis has a scale of 2, but it's still even. Have a look at this graph and try to picture in your head where that last point belongs. That's 12 and 65. On this x-axis, where does 12 and 65 belong? There you go, right there, 12 and 65. And that's because this time each one of those vertical lines is worth 2. All right, let's have a look at the line of best fit. I don't want you to try to copy the graph that you see on the right-hand side of the screen. I would like you to write down the text that you see on the left-hand side of the screen. So don't copy the graph on the right. Do copy the text on the left. So what do we mean when we say a line of best fit? First of all data points in science are understood to be imperfect. We know that our observations have small flaws in them called errors. The line of best fit then is trying to show us the average trend in our data, knowing that all of our points are just a little bit wrong anyway. The line might be a smooth curve, or it could be a very straight line as it is in this example. There might be two trends in the one graph, but we'll talk about that more in class tomorrow. All right, let's take a closer look at that graph that you see. But again, from here on in, I don't need you to copy anything further. Just watch what's happening on the video. All right, so there's our graph blown up nice and big. You can see that dotted line is running up the middle of all of our data points. Some of our points lie right on the line, 3 of them do, but not all of them. There are 2 points that lie above the line, and there are 2 points that lie below the line. And the points that are above are kind of the same distance from the line as the points are that lie below. So the line is going right up the middle of all of our data. Also notice that the line does not extend past the very last point that we've plotted. And that's because out past this point, which is 7 and 20, we haven't recorded any data, so we have no idea what might happen out there. So we can't predict a trend yet because we just don't know what's happening. So we just don't draw the line any further. Also, the very first point that we recorded was 1 and probably about 3. So I start my line from there. I do not need, in fact, I should not attempt to draw that line back through 0, 0, unless 0, 0 was a point that I recorded. So our trend line, our line of best fit, flows up the middle of the data. It's an average of all of our data points. It starts with our data and it ends with our data. And we'll practice a bunch more of those when we see each other in class.